number 6D involves a double square root. In double square roots, we have to be a bit careful because we need to undo both square roots, but we cannot undo both square roots at the same time. So for example, if I squared this, I cannot square those terms individually because of that plus in there. So I have to expand it out, and I'm going to generate another square root term. Now a good way to do this is we can isolate the square root parts. So for example, I can isolate x minus 3 square root by subtracting square root x from both sides. And by doing that, I'm going to then allow myself to undo the square root. So squaring both sides. So I end up with x minus 3, and that's equal to, I have to remember to expand this out. So when I expand this out, I get 81, and then negative 9 root x twice, so I get negative 18 root x, and then squaring the negative, I ended up with plus, and the square root squared, I end up with x. Now conveniently, this is going to cancel out, the x's cancel out here, so I'm just left with that square root to solve for. So I'm going to add 18 root x to both sides to make that positive. I'm going to add 3 to both sides to get rid of that minus 3. So I end up with 84. And then dividing both sides, I end up with 84 over 18. Okay. And then finding a common factor here, I'm going to simplify this to square root. The common factor here is 6, so I'm going to divide both sides by 6, it looks like. Yeah, 6 looks like it divides in, so I end up with 14 over 3. And then squaring both sides, I get x is equal to 196 over 9. And I can check that by substituting that back in for extraneous solutions. So this is my check. Checking this, I get square root 196 over 9 plus the square root of 196 over 9 minus, and this will be 27 over 9, subtracting the 3, and that should be equal to 9. When I work this out, this is 14 over 3 plus, when I subtract this, I'm going to end up with 169 over 9, and 169 over 9 simplifies to 13 over 3 when I square root it, and that's equal. So 27 over 3 is equal to 9. That is a correct solution. Since it's a double square root, I really should graph this. So when I graph this, it looks like this. And I can find the intersection here at 21.78, which is the same as 196 over 9. So this graphical solution also shows me that there are no extraneous solutions here because the intersection points there, the extraneous solution would be generated by having that other part of the parabola here.